Okay, so yesterday we started looking at solving equations. And again, what we're trying to do is we're trying to find the value of the variable. The variable is a letter, an unknown value that's part of an equation. We're trying to find the value of that variable that makes the equation true. So yesterday we did one-step equations where there's only one step involved in solving it. We either added or subtracted a value from both sides, or we multiplied both sides by a value. Sometimes we divided both sides by a value. Today we'll look at two-step equations. So in order to solve these, we need to work backwards from order of operations. Again, the goal is to isolate the variable, getting it to be alone on one side of the equal sign. We do this by performing the opposite operation and doing the same operation to both sides of the equation. So that part's not different than what we did yesterday. You look and see what you're trying to get rid of, how is it hooked together with the rest of it, and do the opposite operation. So, again, it says algebraically solve the equation, so that means you need to show some algebra. That means you're moving things around in an equation. And then check our answer. So remember, the order of operations say that normally we do our multiplication and division first, or adding and subtracting second. That's what order of operations tell us. Remember the acronym BEDMAS. You've seen it before. This tells us what the order of operations are. B for brackets, you do what's inside the brackets first. E for exponents. If there's any exponents, you do that next. D is for divide, M for multiply. You divide and multiply from left to right, and then A for add, S for subtract. You add and subtract left to right. Those are the order of operations that we follow when we have an expression with multiple operations. To solve equations, you do the opposite, which means you're going to do your adding and subtracting first, then you do your dividing and multiplying in order to get a variable by itself. So, looking at question A, we want to get Z by itself. Find out what Z equals. But before we can get Z by itself, we have to first get the 2Z by itself. So what's hooked on to the 2Z, princess? A minus 6. What's the opposite of subtracting 6? Adding 6. So that's our first step. We're going to add 6 to both sides. This is algebraically solving. We're showing what we're doing to both sides. So the minus 6 plus 6 on the left cancels. And you've got the 2Z by itself on the left. And on the right side, 18 plus 6 is 24. But we're not done. What next, Keen? You're going to divide 2 by 24. So 2 divided by 24 is 1/12. Well, that's not what you said, though. Which is it? Which is it? You said two different things there. Actually, you're going to put your phone away first, and then you're going to say you'll divide both sides by 2, because that's what you have to do. You have to divide both sides by 2, not just the 24 by 2, both sides by 2. And the whole point of doing that is so that the 2's cancel on the left. Now you have Z by itself. And on the right side, 24 divided by 2 is 12. Put your phone away, Keen. I want you to copy this stuff down. And there's our answer. So now we're going to verify it. That's another way of saying we're going to check it. 2Z take away 6 equals 18. Again, you start with the original equation. The equal sign divides the equation into two sides, left and right. The right side is 18. We need to show that we get 18 on the left as well, when Z is 12. So 2 times 12, take away 6. 2 times 12 is 24. Take away 6 is 18. You get the same answer on both sides. That tells us that our answer is correct. Our solution is correct. We just checked it. You should never get these wrong, because you can always check to make sure that the answer that you get is the correct answer. Question B. Before we can get the Z by itself, we have to get the 5Z by itself. What's our first step, Kyler? Say again? I didn't hear what you said. from both sides. Is that right, Jan? He said minus 16 from both sides. Is that right? Yes. To get rid of the plus 16 attached to the 5z, the opposite of adding 16 is subtracting 16. So 16 minus 16 cancels on the left. You're left with 5z for now, equals 51. Take away 16 is 35. Now what, Kiana? No, that's exactly what you do, because right now I have written 5z equals, did you say z? Are you from the USA? Okay. That's what people in the USA, they say z instead of z. Hmm? No, because I say z. I'm glad we had this talk though. But you're right, because right now I have 5z equals 35. To get the z by itself, you got to get rid of the 5 in front. They're hooked together by multiplication, and the opposite of that is division. Divide both sides by 5. So on the left side, 5 divided by 5 cancels. 5 divided by 5 is 1, so you'll get 1z, or just z, equals. And on the right side, 35 divided by 5 is 7. So again, we're going to verify. Once again, the equal sign, remember, divides the equation into two sides, left side and right side. The right side is 51. We need to show that we also get 51 on the left side when we let z equal 7. 5 times 7 is 35, plus 16 does equal 51, so it checks. We've just shown that our equation is satisfied when z equals 7. Okay? Question C, Ava, first step. You agree with that, Kira? Absolutely. Because the negative 4x and the 8 are hooked together by subtraction. The opposite of subtracting 8 is adding 8. That's our first step. And the reason we do that is so on the left side, the minus 8 plus 8 cancels. And we've got negative 4x equal 20 plus 8 is 28. Now what, Keen? Now what? You're going to divide both sides by negative 4, he says. Is that right, Charlie? Good. Because the negative 4 and the x are hooked together by multiplication. The opposite of that is division. So on the left, negative 4 divided by negative 4 is positive 1. You'll get positive 1x, or just x equaling. On the right, 28 divided by negative 4 is negative 7. So there's our answer. And that's what we're going to use in our check. Once again, the equal sign divides the equation into two sides, left and right. So on the left side, we'll let x equal negative 7 in the equation. Negative 4 times negative 7 is positive 28. Take away 8 is positive 20. So it checks. We've just shown that our answer is correct. Remember, when it says verify, that's the same as checking. So you should never get these wrong. You can always check them. Question D, first step, Jace. Yes, sir. First step. You agree with that, Princess? That's what he said. First he said subtract, then he said add. So add 5.7 to both sides. And the reason we do that is because on the left, a minus 5.7 plus 5.7 cancels. And we have 2.3a on the left equaling 3.96 plus 5.7, 9.66. The fact that we have decimals there doesn't change the way it's done. Now what, Riley? Divide both sides by 2.3. So on the left side, 2.3 divided by itself gives you 1a or just a equaling. And on the right side, we need to use our calculator to divide. 9.66 by 2.3. We get an answer of 4.2. And that's what we're going to use in our check. So 2.3 times a, which is 4.2, take away 5.7. 2.3 times 4.2 is 9.66. That we now have to subtract 5.7 from. And we get the same number on both sides, 3.96. So we've just shown that our answer is correct. It works. All right, question E. Didn't see one like this yesterday where the variable was on the bottom, but it doesn't change the way it's done. Okay? We want to get rid of the fraction on the left. So we need to get rid of the x that attaches to the 15. And it's attached by division. So we do the opposite, which is multiply. We're going to multiply both sides by x. So I'll multiply the left side by x and the right side by x. And what happens on the left side is that the x's cancel. X divided by x is 1. You'll get 1 times 15 or just 15 on the left. And on the right, you have 6x. On the right side, you multiply the 6 by the x. That gives us 6x. And now we want to get x by itself. How do we do that, Katie? How do we get x by itself? Divide both sides by 6. Sorry, I said KT. It should have been Kate. Divide both sides by 6. And so we're going to get a decimal here, which is fine. 15 divided by 6, exactly 2.5. The fact that it's a terminating decimal means we can use it. If we get a repeating decimal when we're doing this, we can write it down rounded, but it's better to leave it as a fraction in lowest terms. If you use a rounded value in your check, it won't work because it's not exact. But because we get exactly 2.5, we can use that. So when we use our check here, it's 15 divided by x. You always start with the original equation. Again, the equal sign divides it into two sides, left and right. The right side is 6. The left side should also work out to be 6 when we let x equal 2.5. So 15 divided by 2.5. Get the same number on both sides. Okay? Lena, what do we do for question F? Multiply both sides by 2. Yes. This is like we did yesterday. This is basically a one-step equation. You want to get rid of the 2 beneath the y. They're hooked together by division, so you do the opposite. Multiply both sides by 2. And the whole point of doing that is so on the left side, the 2's cancel. 2 divided by 2 is 1y, or just y. And on the right side, we get our answer of 14. Are we done, Kiana? Put your phone away. We got to verify it. So we're not done. And no matter how obvious it might seem that your answer is correct, like in this case here, because 14 divided by 2 equals 7, if it tells you to check or verify, you need to do that. On a quiz or a test, you'll lose a mark if you don't. If you're told to verify or check, make sure you do that. Question G. First step, Brooklyn. You agree with that, Callum? Yes, absolutely. Before we can get the x by itself, we have to get the x over 2 by itself by adding 1 to both sides. And the minus 1 plus 1 cancels, which leaves us x over 2 on the left equaling 7 on the right. Now what, Jackie? Times both sides by x, she says. Is that right, John? Right, because the x and the 2 are hooked together by division. It's a 2 you're trying to get rid of to get x by itself. So we have to multiply both sides by 2. Because on the left, 2 divided by 2 cancels. You'll get 1x or just x. And on the right side, 7 times 2 is 14. So there's our answer. That's what we need to put in our check to make sure that our answer is correct. So on the left side, we'll have 14 divided by 2, take away 1. 14 divided by 2 is 7. 7 take away 1 is 6. Question H looks a little bit different than what we've seen before, but it doesn't change the way we do it. Before we can get x by itself, we have to get the x plus 5 by itself. And hooked onto that is the 3 by division. So the opposite of dividing by 3 is what, Hannah? Multiply by 3. So in this case here, what I'm going to do is I'm just going to put the x plus 5 in brackets, just so it's clear what we're doing. But this shows that I'm multiplying both sides by 3. And on the left, the 3 divided by 3 cancels. You're going to get 1 times the x plus 5, or just x plus 5 on the left. And on the right side, 30 times 3 is 90. Now what, Kyler? How do we get x by itself? You agree with that, Arpit? Absolutely. Whoa. So on the left, the plus 5 minus 5 cancels. You've got x by itself. And on the right side, you're going to get a number 85. So that should be our answer. That's what we're going to put in our check. And again, always start with the original equation. The equal sign divides it into two sides. The left side is x plus 5, or 85 plus 5 all over 3. You're going to get 90 over 3, which is 30. So it checks. Okay. Question I. First step, Courtney. Subtract 5 from both sides. You agree with that, Shyla? Sure. Before we can get the x by itself, we have to get the 9 over x by itself. Hooked onto that as a plus 5. The opposite of adding 5 is subtracting 5, which we do to both sides. So that gives us 9 over x on the left equaling 8 take away 5 is 3. What do you think we do now, Jackie? Yeah, multiply both sides by x. Because we have to get the x up on the same level, the top level, so that we can get it by itself. So yes, absolutely. Multiply both sides by x would be the next step. And that works because on the left side, the x's cancel. X divided by x is 1. 1 times 9, which is just 9, equaling 3x. Are we done, Charlie? What else do we have to do? Yes, we still don't have x by itself. The opposite of multiplying by 3 is dividing by 3. On the right side, 3 divided by 3 is 1, so you'll get 1x or just x. And on the left side, 9 divided by 3 is 3. So when we check it again, the equal sign divides it into two sides, left and right. The right side is 8. We need to get 8 on the left side as well. 9 divided by 3 is 3, and 3 plus 5 does equal 8. So we've just shown that our answer is correct. It works. Question J. First step, Jace. Subtract 6 from both sides, he says. You agree with that, Shiloh? Because the opposite of adding 6 is subtracting 6, so they cancel on the left. And we still have a minus 4 over 3 equaling 9 take away 6 is 3. So now what, Shiloh? Well, before we can get the a by itself, we have to get the a minus 4 by itself. So we need to get rid of that 3 on the bottom. That's got to be our next step. Remember, you always do your multiplication and division first, adding and subtracting last. So how do we get rid of that 3 on the bottom? Jan, what's the opposite of dividing by 3? Multiply by 3. And I'm going to put the a minus 4 in brackets just to keep it together. So you should see then that, well, 3 divided by 3 is 1. They cancel. You'll get 1 times a minus 4, which is just a minus 4 on the left, equaling 3 times 3, which is 9 on the right. Now what, Courtney? Yeah, add 4 to both sides. Because on the left, minus 4 plus 4 cancels. We've got a by itself. On the right side, 9 plus 4 is 13. So there's our answer, and that's what we need to put in our check. Again, the equal sign divides it up into two sides, left and right. The left side is a minus 4. 13 take away 4 over 3 plus 6. 13 take away 4 is 9. 9 divided by 3 is 3. And 3 plus 6 equals the same number we got on the right. It checks. Our answer is correct. We just showed that it works. So try that first one on the bottom on your own. First step, Keen. To what? Both sides. Because we need to get rid of the division by 3 on the left. So the opposite of that is multiplying both sides by 3. So they cancel on the left. You'll have d minus 2 equal 5 times 3, which is 15. Now what, Ava? Add 2 to both sides, you bet. The minus 2 plus 2's cancel, and you'll get d by itself on the left. 15 plus 2 is 17 on the right. That should be our answer. So that's what we're going to put in our check. Seventeen take away 2 all over 3. 17 take away 2 is 15. Divided by 3 is 5. So it checks. We've just shown that our answer is correct. Okay, try that next one on your own. Done already, Kyler? Really? What'd you get for an answer? 8? Want to bet a pop on that? Well, you should have, because I think you're right. I think you're right. So what'd you do to get that, Kyler? Yep. So on the left side, the minus 4 plus 4 cancels. We'll have 2a plus 5 over 3 equaling 7 on the right. Now what? Yep. So on the left side, 3 divided by 3 cancels. And you'll have 2a plus 5 equaling 21. Then what? And 21 minus 5 is 16. And lastly, divide both sides by 2. 2 divided by 2 cancels. You have a by itself on the left. 16 divided by 2 on the right is 8. So just to show that that is correct. Speaking of Pops, Keen, do you have a job? You have a job. Well, you should get one. So you can pay me my Pop. So here's our check. We're showing that a equals 8. We plug it into the equation. 2 times 8 is 16. Plus 5 over 3, take away 4. 16 plus 5 is 21. Divided by 3, take away 4. 21 divided by 3 is 7. Take away 4 does equal 3. It checks. We get the same thing on both sides, which means that our answer is correct. Okay? All right. I'm going to hand out the assignment. This one I'm going to collect for marks. So you need to